Good morning everyone. I'm Peng with MATRIC number of 22004663. Today I'm going to present about the application of Mosfet in biomedical field. First of all, what is Mosfet? The full name of Mosfet is Metal Oxide Semiconductor Field Effect Transistor. Mosfet has four terminals which are source, gate, drain and body. However, the body of the Mosfet connects with source terminal, thus forming a three-terminal device. There are some characteristics of Mosfet. The first characteristic is Mosfet is voltage control device, as the gate voltage determines whether the state of the Mosfet is on state or off state. The second characteristic is Mosfet can be easily scaled down in size for the fabrication of complex ICs. The third characteristic of the Mosfet is Mosfet has low on resistance, so the power dissipation can be reduced. The fourth characteristic is Mosfet has high input impedance, so they require minimal input current to control the device. Next, Mosfet has low power consumption, so they are energy efficient. Besides, Mosfet has fast switching speed, so it makes Mosfet a good switch in the electrical application. Moreover, Mosfet has good thermal stability, so they are unaffected by the temperature changes. Last but not least, Mosfet produce very low noise. Here are some functions of Mosfet. First of all, Mosfet acts as switch, as it can switch rapidly between on and off states, allowing for efficient control of electronic signals and data processing. Next, Mosfet acts as storage cells, holding and retrieving digital information by altering the charge stored within the transistor floating gate. Furthermore, Mosfet is used as amplifier in analog circuits. Lastly, Mosfet is used in current control and voltage regulation. The medical device I choose is pulse oximeter. It is a medical device used to measure the oxygen saturation level in a person's blood. It works by emitting light wavelengths, typically red and infrared, through a person's fingertip, earlobe, or other body parts. Pulse oximeter measures the amount of light that passes through the blood and calculates the oxygen saturation level based on the differences in absorption. The type of Mosfet used in pulse oximeter is N-channel E-type Mosfet. Here are the rows of N-channel E Mosfet in pulse oximeter. Firstly, the photodetector detects the light absorption by oxygenated and deoxygenated blood and generates a corresponding analog signal. This weak analog signal represents the changes in blood oxygen saturation. Next, the initial weak analog signal from the photodetector is typically very small and requires amplification for further processing. The E-MOSFET is biased in the linear or triode region, acting as an amplifier. Later, the weak analog signal is coupled to the gate terminal of the E-MOSFET. As the input signal voltage varies, the E-MOSFET amplifies the signal by providing voltage gain. A load resistance is connected to the drain terminal of the E-MOSFET to convert the amplified current variation into voltage variation. Lastly, the amplified and converted signal is further processed in subsequent stages to determine the oxygen saturation levels. This diagram shows the circuit design in pulse oximeter. That's all from me. Thank you.